This is the NEAP 2009 exam 2, question 12. So it's saying a transformation that maps the curve with this equation. So this is the old or the pre-image onto the curve with equation y equals 1 minus 3 sine 2x plus pi. That's the new, or the image. And what transformation matrix maps sine x to this? And we can kind of guess, but perhaps writing this out in a new way might help. So let's start with minus 3. I'm going to make sure that the coefficient of x is 1. And I'm going to add the 1 at the end. So we can kind of see that we needed a reflection across the x-axis. We need a dilation of factor of 3, a dilation by a factor of a half here, translation of pi into to the left, and a translation up of 1. So what sort of matrix creates that? And I thought the best way to do that is to illustrate that with a table that we've seen before. So we can see here that if we have a reflection in the x-axis, that's the kind of matrix we're looking for. Reflection in y, dilation by a factor of k, etc., etc. So what we're looking for is a reflection, this one. So we want a negative value at this matrix, at this part of the matrix. We had, so that's that reflection there. We've got a dilation by a factor of 3. In fact, I might just rewrite this. So we can see we want a reflection there and a dilation. So really we want that to be a minus 1. And we want this value of k to be 3. We have a dilation by a factor of 2, by a factor of a half. So it's 1.5. So this value here is going to be, actually that should be a 3. I just said that that would be 3. This would be a minus 3. That k there would be a half. And we're shifting by pi on 2. We're shifting it, I'll just bring this up a bit. We're translating b units to the right, but that is x minus b. We get an x plus b, so we're shifting to the left. So that there would be a minus pi on 2. And we go up 1, so that would be a 1. So really if we had a translation matrix which looked like this, we could start with a 0, 0, b, x, y, plus c, d. We could say that a would need to be, that's a dilation factor from the y-axis, so that would need to be a half. That's this part here. This b would be minus 3. And the c would need to be negative pi on 2. And d would need to be 1. And so we get a solution of d. There is another way to do this question, and that is to consider a transformation matrix like this and then equate coefficients. So I've done that over the page. We can see here we just multiply an unknown transformation matrix, x dash y dash. If we multiply out the matrices, we get these expressions here, x dashed equals ax plus c, rearrange to make x the subject, y dash, rearrange y dash to make y the subject. And since y equals sine x is our old, or our pre-image, it is this curve that we want to transform. So we're going to substitute values for x and y in for x and y. And if we substitute those values, y dash minus d over b goes in for y, x dash minus c over a goes in for x, and we get this expression. We solve this for y, multiply by b, add d to both sides. I've also rearranged this expression inside the brackets so that I have two fractions. That'll become obvious in just a sec. Then I get an expression for y dash, and I want to equate that with my transform function. So this now is y dash in terms of x dash. So it's my transform function, but my transform function looks like this. We are going from sine x to this expression here. So I can just equate coefficients. B is equal to minus 3. There it is. 1 over a is equal to 2. So I get a equals a half. Minus c over a is equal to pi. So I get c equals minus pi over 2. And d equals 1. And that gives me exactly the same solution as I got earlier. Just a different technique. That technique, this one over here, is probably something we would use in a calc-free question.